back. Welcome back. This is video 4 of our game development learning within the Unreal Engine 5.2.1. And yesterday I'll just do a quick recap. We've already got our box collision for a trap and pieced together the fisherman's hut with a collision box to open the door. One thing I need to do is learn about pickups, keys, and how that interacts with the door. That's to do, yeah, it's quite a lot to learn there. But this is what we did yesterday. So we've got a really cool. I'm very happy with the design I've done in here and placement of key objects and things. So today we're going to be learning the AI. Now for my assessment, I have to, if you want to get the higher marks, you need to have hostile AI enemies. Now the reason I'm doing this now, I know it's quite advanced and it's a lot further down the assessment, but I want to have it in there because following on from that, we're going to be creating a health bar that is affected based on traps, enemies. So it kind of all links together. So I want to get some basic AI done so that I can then straight after that jump onto the health bar mechanics and make sure that when player comes into contact with an enemy, they they basically lose health, and I wanted to just, instead of pressing like, I don't know, one or two to just play around and make the health bar activate, I wanted to actually have some enemies that I could just run into and test it. It's just, just want to get that bit done. So what I'm going to do here, I'm just going to expand the area. So I'm just going to grab the floor and we are going to hold Alt and drag that. Oop, I thought I had the green. Oh, there we go. Okay, so now I can delete that wall, and I'm just going to duplicate this one here. Hold on. Huh. Not a problem. I'll just scale that on the Y axis. No. There we go. Okay, and then we should be able to copy that one and just move that over here. Cool. Okay, let's go save. Always good to save the project. Okay. Right, so what I'm going to do here, guys, I've got the official, found some documentation from the Unreal Engine, which is really good. Instead of just finding random tutorials online, I'm using the actual documentation for the engine. And it's really good, you can actually filter the documentation based on the engine version, so there's a big drop down. So, okay, so what we're going to be learning today is the behavior tree. So I've got a quick start guide, so I'll just read it out. So it says you'll learn how to create an AI enemy that responds to seeing the player and proceeds to chase them. While losing sight of the player after a few seconds, which can be adjusted based on your preference, the AI will give up chasing and randomly move around the environment until seeing the player again, as seen in the example video below. So by the end of this guide, we will have an understanding of Blueprint visual scripting, which we've already been using, AI controllers, blackboards, behavior trees, behavior tree services, behavior tree decorators, and behavior tree tasks. So I've got a required project set up here. Create a new folder. Right, so we need to create a new folder. Welcome to Stream Exotic. Thanks for the comment. So we're going to bring up our folder here in the content drawer. And I'll just go all. So this tends to be, yeah, this is all the stuff. What I'm going to do, under first person, under all content first person, I'm going to make a new folder and we're going to call this AI. Okay. Okay, right, so now it's saying in the third person blueprints folder, but I've called this, hold on, 1 second. Create a new folder called AI, done that. In the third person blueprints folder, drag the blueprint third person character. Into the AI. What's this one? BP Blueprint Third Person Game Mode. 1 second. What is going on here? I feel like I've missed a step. Open the content drawer, right click on the third person folder, create a new folder called AI. Well, I'm in first person, so I've put it in there. I've done first person AI. Done that. Right, so it's saying in the first person. Right, so what I'm going to do, I'm going to go in, let me just double check. 1 second. Right, so we're not in third, so we're in first. So it says go into blueprints folder, drag the BP, I'll make this a little bit bigger, onto the AI folder and select copy here. Right, so I just, oh, oh, that's good. AI, copy here. Okay, done. In the AI folder, create a new blueprint class. Based on the AI controller class. Right, 1 second, guys. Create a new blueprint class. Yeah, this is blueprint class based on the AI controller class. So we click on here and we put in AI controller. AI controller. Okay, right, this is the one we need, AI controller. Select. And we're going to call this, hold on. Oh, there we go. We're going to call this No, didn't want to do that. I want to name it. Where's rename? There we go. Right, so I'm going to call this. Ah, right, okay, so it's getting us to. 1 second. Right, name the AI blueprint, enemy controller, and the BP third person controller, enemy character. Okay, so I'm going to call this, because I know I'm using a wolf, so I'm going to call this. I'm going to call this wolf controller. And I'm going to call this one. Why is it getting me to change the blueprint to enemy underscore character? Why would it not keep the BP naming conventions? Let's just go with it. This is from Unreal themselves. Okay. No, hold on. Enemy underscore character, enemy underscore controller. So I've got wolf underscore controller. So I gotta call this wolf underscore character. Okay. Right. Open enemy character. So this one. Oh my god. Right. Okay, so these are the mechanics of the first person controller. Right, so open wolf underscore character. Right, so it says delete all the script from the graph. Goodbye. Select the character movement component. This one here. And then set max walk speed in the details panel. Max walk speed. Character movement, walking. Max walk speed. Right, so we just put, it's telling us to put in 120. So 120. Okay. What is this one beneath it? What does that say there? That's when walking and crouched. Okay. Right. This reduces the speed of our AI character's movement around the environment when patrolling and not chasing the player. Okay, so that's just random walking around before we come into the scene. Select the class defaults from the toolbar, and then in the details panel, assign the enemy controller as the AI controller class. AI controller class. Oh my god. Right, it's not that far down the scroll. Oh god, we got the scroll. Right, okay, hold on. Right, so we're on the class default, so we're looking for AI controller class. Oh, I need to bring that up larger. Right, so we're looking for pawn. Not pawn as in P-O-R-N, pawn as in P-A-W-N. Right, I'm looking for pawn. I'm looking for pawn. Oh, there is a lot of stuff here. Where is the pawn? Oh, sod it. I'm going to type in pawn. I can't be asked to scroll through that. There we go. Okay. Right. We found the pawn. Why? Hold on. There we go. Okay. Right, so under pawn, we need to change the AI controller class. AI controller class. So this is going to be enemy controller. So that will be wolf controller. There we go. Okay. I'm just going to expand that just a little bit so we can see some of those details a bit better. Okay, so we've cleared the blueprint graph. We've gone on a character movement. And we found the pawn. We've done that, and then hold on, where's the pawn gone? Oh my God, what did I just do there? I just want to know where the pawn thing was. Would it be movement component? So because I've actually searched for it instead of scrolling through tons and tons of stuff. It's actually, can I expand? Oh, there we go. Where has it disappeared to? I do feel like I need to locate this. Oh, this is really annoying. Why? Expand all categories. Jesus, Mike, come on. Right, so where was that pawn? Character component. I'm just going to backtrack because this has confused me. Right, set the max walk speed. We've done that, 120. Oh, it was the class defaults. So where? There we go. Right, so there. Okay. So sorry, I was looking under different things. So I was looking here, character movement, and then it's class defaults, and we've done the wolf controller. Right. So now we're going to place our AI in the world. If you spawn the AI after the world is loaded, change the auto possess AI setting to spawned. We are going to place our AI in the world. If you spawn the AI after the world is loaded, I'm just going to put it in the world, right? So okay, from the content drawer. Okay, I'm going to put this actually up there. So we've docked it up the top here, guys. So we're going onto the first person world, and from the content drawer, drag the enemy character. So that would be wolf character. There. Okay. So there is our wolf, and I created this little arena here. So we've got an area for the wolf to patrol in. Okay. Right, from the place actors panel, drag a nav mesh bounds volume. Right, so nav mesh bounds volume into the level. So I'm going to put that there. With the nav mesh bound selected, press R and scale the volume to encapsulate the entire level. Well, I don't want to do the entire level. I just want to do this section because we're actually, each little block is a section we've been working on for our learning. So um, I'm going to basically set this to there we go. I'm actually going to set this to just trying to make sure that lines up correctly, guys. That's pretty good. Right, it shouldn't be able to pass through those walls because it shouldn't. There we go. So that's almost, I think I'm happy with that. You can see that's pretty much online there. Okay, so we've created our nav mesh bounds. So I believe this is the area that the wolf will be patrolling in. So this will generate a navigational mesh that enables our AI character to move around the environment. You can press the P key to toggle the display of the nav mesh in the viewport. Green areas indicate possible navigation locations. Hmm. Okay, I'm going to shrink that just a tad. Yeah, I'm very happy with that. That is, it's not conflicting. It's not touching any of the edges. Like there's enough. Yeah, there's definitely enough of a gap there. I'm happy with that. So this theoretically, I'm learning this from scratch, right? So my understanding just from this alone is literally we've just created the boundary for the AI to roam in. Now, before I even started doing this, I assumed it would be like a matter of putting up invisible walls and using planes. That's how I thought it might have been done, but yeah, it's just exciting learning all of this. Right, so I'm going to press P to hide that. Our project setup is complete. And the next step, we will set up our Blackboard asset. Okay. Right, in this step, we create our Blackboard asset, which is essentially the brain of our AI. Anything we want our AI to know about will have a Blackboard key that we can reference. We'll create keys for keeping track of the player, whether or not the AI has a line of sight to the player, and a location where the AI can move to when it is not chasing the player. Okay. In the content drawer, click add artificial intelligence and select Blackboard. Call it BB enemy. Right, so well, it's not going to be BB enemy. This is going to be BB wolf. Because if you remember, the naming conventions in this tutorial were saying to name the bit I've named wolf, it was to name it as enemy. So what we're doing here is because we're going to have two different enemy types. We're going to have a crow and then we're going to have a wolf. So instead of just having enemy, that could be generic to all enemies. I don't want that. So I wanted to have the two different AIs, which are basically going to be almost identical. Right, so we've done the blackboard. Inside the blackboard enemy board, click the new key button and select object. The blackboard asset consists of two panels. The blackboard, which enables you to add and keep track of your blackboard keys, variables to monitor, and blackboard details, which enables you to name and specify the type of keys. For the object key, enter enemy actor as the entry name. So we're going to call this wolf actor as the entry name. Hold on. 1 second. Oh yeah, I've done it correctly. Right. Right, so for the object key, enter enemy actor. So we've put wolf actor as the entry name and actor as the base class. So we click here, the base class is actor. Okay. Add another key with the key type set to bool. I'm guessing that might refer to Boolean. So add another key with the key type set. Okay, right. So we're with the key type set to bool. Right. Okay. So key type is. So we just click on that one. Okay. So we've got key type is set to bool, and the entry name is going to be has line of sight. Okay. This will be used to keep track of whether or not the AI has a line of sight to the player. Add another key with the key type set to vector. Vector. Great game. Vector Man, Sega Mega Drive. Aaron, welcome to the stream, bro. How you doing? I'm just going through an actual Unreal Engine tutorial by them themselves. This isn't a tutorial by YouTube or anything. This is literally from the belly of the beast themselves. So I'm setting up some AI. I'm really excited about this. NPC AI, not ChatGPT or any of that bollocks. Okay, so we had another key. This is called vector, and this is going to be called patrol location. Patrol. Why is that not typing? Just literally selected that. Patrol location. This will be used to keep track of a location. Oh, get well soon, dude. Get well soon, mate. Make sure you have some lem sips. Have some lem sips and rest up. I'm doing very good, mate. I got to bed quite late. I've been doing like 4.5 hours of dev yesterday, and then I hadn't eaten all. I had like breakfast. I had my lunch was basically my dinner, and then I was just chilling out for like an hour and a little bit, and then I don't know. I was just thinking about dev and user interface, and then I ended up creating widgets. Well, the graphics to go into the widgets for the score display, timer display, and the health bar. So I just I was just the creative juices were flowing, and yeah, and here I am again doing more work, learning the system. I'm enjoying it, really enjoying it. Right, so what I'm doing is I'm doing AI at the moment for one of our enemies. I'm just kind of reading out what the official Unreal documentation is saying. So this is a really cool learning curve. Right, so this is going to keep track of a location and a level where the AI can move when it is not chasing the player. So basically the roaming area. Our blackboard is set up with the things we need to track. And the next step, we will lay out our behavior tree. Okay. Why have we got one called self actor? I think I can delete that one because that's not actually in, that wasn't actually in, did I find out? No, I'm not being uni today. I'll be in tomorrow. I'll inquire about it, dude. Right, let me just find my bearings on this thing. Right, so we're Blackboard is set up with the things we need to track. Has line of sight, patrol location. Behavior tree layout. In this step, we will lay out the flow of our behavior tree and the states that we want our AI to enter. Laying out your behavior tree with the states you anticipate. Hold on. That sentence hasn't had commas. That reads very badly. Laying out your behavior tree with the states you anticipate your AI could be in as a visual flow will give you an idea of what logic. That needs a bloody comma. Hold on. Laying out your behavior tree with the states you anticipate your AI could be in as a visual flow will give you an idea of what type of logic and rules you will need to create to enter those states. Okay. In the content drawer here, um, we're still in our AI folder. Okay. Uh, add and under artificial intelligence, select behavior tree and call it BT enemy. So BB wolf is for blackboard wolf. BT is for behavior tree underscore wolf. Okay. Naming conventions may vary, but it's generally good practice to add an acronym or the asset type to the name. We've done that. English teacher analysis. I'm not an English teacher. I literally looked at that. It was essentially kind of like a it was a long sentence and it wasn't reading correctly, and I was struggling to read it because it wasn't split up with like at least one comma. It wasn't written well. Okay, open the behavior tree, wolf, and assign the BB enemy as the blackboard asset. Okay, hold on. Behavior tree. Okay, here we go. Blackboard asset, and assign the blackboard wolf as the blackboard asset. Okay, cool. And then we've got the root, and then we've got the blackboard wolf. The behavior tree consists of 3 panels. The behavior tree graph, which is here, where you visually lay out the branches and nodes that defines your behaviors. The details panel over here, where properties of your nodes can be defined, and the blackboard, which is here, which shows your blackboard keys and their current values when a game is running and is useful for debugging. In the graph, left click and drag off the root and add selector node. Place a new node. Selector. Okay. Composites are a form of flow control. Hold on. What kind of games are you inspired by? What ideas do you have that may be similar to other games? I don't want to kind of clone games or, you know, do anything like that. It's a hard question, mate, really, because I've got a lot of games I love. I'm a huge RPG fan, so I think I'd love to be involved in making an RPG. Um, and yeah, I just want to have like have your own world, your own game. Like obviously across many games, a lot of the mechanics are similar, like inventory management, talent trees, s- uh, achievements. Like there's so many things there, but it's all about making it different, isn't it? But like Binding of Isaac's a great one. Dark Souls would be fantastic. What about yourself? Right. Composites are a form of flow control and determine how the child branches that are connected to them execute. So this is a composite, this is the selector. So this executes branches from left to right and is typically used to select between subtrees. Selectors stop moving between subtrees when they find a subtree they successfully execute. For example, if the AI is successfully chasing the player, it will stay in that branch until its execution is finished. Then go up to the selector's parents composite to continue the decision flow. So this is, I think, the parent. Got you. So, okay, I think I understand what's happening here. Sequence. Which is this a sequence? No, it's not. It's a selector. Um, Sequence executes branches from left to right and is more commonly used to execute a series of children. Just reads wrong when you first read that. More commonly used to execute a series of children in order. Unlike selectors, the sequence continues to execute its children until it reaches a node that fails. For example, if we had a sequence to move to the player, check if they are in range, then rotate and attack. If the check, is that a typo? If the check, if they are in range portion failed. Oh, right, okay, that needed quotations. If the check, if they are in range portion failed, the rotate and attack actions would not be performed. Okay. Simple parallel has two connections. The first one is the main task, and it can only be assigned a task node, meaning no composites. Composites, okay. The second connection, the background branch, is the activity that's supposed to be executed while the main task is still running. Depending on the properties, the simple parallel may finish as soon as the main task finishes, or wait for the background branch to finish as well. Yeah, I know, Aaron. When I saw that, I'm a father, so I'm very protective of my kids. But when I read that, I was just like, oh my God. Well, obviously, in coding and dev, like you have the parents and then the children. So like when it comes to objects, static meshes, if you have one cube and then you want to attach spikes to that cube, you drag the spikes onto the cube and the spikes become children to the parent cube. So it's yeah. Um oh nice, good that's pretty good choice of games you got there, dude. Right, for the selector node, in the details panel, which is up here, change the node name to AI root. Okay. Renaming nodes in the graph is a good way to easily identify from a high level what the node accomplishes. In this example, we name it AI root as this is the real root of our behavior tree, which will switch between our child branches. The default root node that is automatically added when creating a behavior tree, default root node, uh, is used to configure properties of the behavior trees as well as assign the Blackboard asset it's using. Left click and drag off AI root and add a sequence node named chase player. Oh, Aaron, you wait until I add in the wolf. You're going to shit your pants. I'm not even joking. It's quite terrifying. Oh, hold on. What am I doing here? Sequence node. Sequence node. Okay, sequence node. And named chase player. I'm scared. I know how terrifying this wolf is. I want my children to test play this, but I don't know. I don't know if they. It might be a little bit too scary. Well, it's not. It's not. It's not really going to be scary. It's just. Yeah. Thanks for tuning in, Pretty. Thanks for the comment. Um, Chase player. Right. We use a sequence node here as we plan to tell the AI to do a sequence of action or a survival. No, no, because I have to think about PEGI ratings, ESRB. You know, if you're restricting your audience, you're restricting the reach of the game. So th this isn't going to be scary with jump scares. You'll see when as we develop the game. I'm allowed to document and stream the process. I've already checked with the lecturers, so it's really nice to be able to document my learning uh, of the software and just development in general. Right, we use a sequence node here as we plan to tell the AI to do a sequence of actions. Rotate towards the player, change their movement speed, then move to and chase the player. Left click and drag off the AI route node and add a sequence called patrol. I know it's a little bit slow at me following these steps, but I'm being very careful not to make any mistakes. I'm just taking my time, making sure I understand what goes where and what its purpose is. Because there's no point in me following a guide, doing it, and saying, yeah, this is mine. But I want to be able to understand what every little bit does. So for our AI sequence, we will use the sequence node, which is okay. Hold on. Right. Okay. Hold on. For our AI, we will use the sequence node to find a random location on the map. Move to that location, then wait there for a while before repeating the process of finding a new location to move to. That is exactly what I was going through my brain last night when I was thinking that's how I want the wolf to move. It just roams in the environment. It stops, has a different animation, and then it continues to a new spot, and the animation changes. Um, right, so then wait there for a while before repeating the process. Right, well, you may notice the numbers in the upper right corner of the nodes. 1, 0, 1, 2. Okay. This indicates the order of operation. Right. Behavior trees execute from left to right and top down. So the arrangement of your nodes is important. Left to right, so left to right and then top to down. So top's got priority then, because it goes 0, 1, 2. Okay. The most important actions for the AI should usually be placed to the left, while the less important actions or fallback behaviors are placed to the right, such as patrol. Child branches execute in the same fashion, and should any child branch fail, the entire branch will stop executing and will fail back up the tree. For example, if chase player failed, it would go back up there. It would return to AI route before moving on to patrol. So it kind of, if this fails, it goes bonk and then it goes across to patrol. Right. So this, okay, right. Okay, I'm understanding. So left, so top is the priority and then it goes left to right. Okay, drag off AI route. Right, drag off AI route. Okay. and then add a wait task. Wait task to the right of patrol with a wait time set to 1. Okay, wait time set to 1. So it waits 1 second. Okay. You will notice that the node is purple, indicating that this is a task node. Task nodes are the actions that you want the behavior tree to perform. The wait tasks acts as a catch-all. The wait task acts as a catch-all if the behavior tree fails both chase player and patrol. Just trying to understand that. So if these two fail, it waits. So that's kind of like I'm just trying to think, I'm comparing this to RuneScape right now. So if you came to an enemy, they'll hit you. But if you then ran out of the area, like they would try to engage you, but if you ran out of the attack zone, they would like wait there, and then after a few seconds, they would return to their roaming. So that is essentially what this command is doing. So it's saying, if these fail, then there's a wait process, and then it will probably like return to its normal activities. So you'll notice it's purple. These nodes are the actions. The wait task acts as a catch-all. Right. Drag off the chase player. Okay. So drag off the chase player and add a rotate to face BB entry node. BB entry, so blackboard. Hold on. Where is BB entry node? I don't remember seeing a BB entry node. Where's that come from? What? Entry. Drag off the chase player and add a rotate to face. Rotate, right, okay, rotate to face BB entry. And add a rotate to face BB entry node. Okay, so save all. Oh, this particular task enables you to designate a blackboard entry that you want to rotate and face. In our case, the enemy actor player. Once you add the node, if you my brain's starting to get a little bit confused with something. I'm not going to worry about that yet. I'm slowly following this task. Right, so drag off the chase player and add a rotate to face. Right, so rotate and face, in our case, the enemy actor, in brackets, player. So I think I've misread this because it's saying enemy actor, but everything's been named enemy actor. I assumed that would have been like the NPCs, not the actual player. We can always rename where we've put wolf actor, we can rename it to enemy. It's fine. I can. Just a simple change. Okay, so this particular task enables you to designate a blackboard entry that you want to rotate and face. In our case, the enemy actor. Once you add the node, if you look in the details panel, the blackboard key will automatically be set to enemy actor because it filters for the actor blackboard variable and it's the first one on the list. You can adjust the precision option if you want to tune a successful condition. You can use the precise option. What precise option? Is that precise? Oh, I've just misread something. Sorry. You can adjust the precision option if you want to tune the success condition range as well as change the node name. Success, okay. From the toolbar, click, I'm just going to save again. From the toolbar, click the new task button. Create a new task node blueprint from a base class. Alright, new task. In addition to using the built-in task, you can create and assign your custom tasks that have additional logic that you can customize and define. This task will be used to change the movement speed of the AI so that it runs after the player. When you create a new task, a new blueprint will automatically be created and opened. In the content drawer. Why do I say drawer? It's drawer. Okay, so we're going to call this blackboard. Right, so this is BBT, which I think stands for, I don't know what the BTT stands for. Oh, behavior tree task. Behavior tree task underscore. Chase player. Hope you're enjoying it, guys. Okay. In the content drawer, rename the new asset as BTT Chase Player. BTT Chase Player. Done. It's good practice to immediately rename any newly created tasks, decorators, or services when you create them. Proper naming conventions would be to prefix the name of the asset with the type of asset you create, such as BTT for behavior tree tasks, BTD for behavior tree decorators, or BTS for behavior tree services. Inside the BT enemy, which is BT wolf, inside the BT wolf, add the BTT chase player task. Add the BTT chase player, which is that task, followed by a move to BTT chase player. Okay. And then a task followed by a move to. Notice that these have numbers. So I understand what's happening. Right, I wonder if I move that there. Yeah, that's interesting. If I move that way, you can see the numbers are changing. I think I prefer to have them like that. It just looks a bit neater. Rotate to face. No, it's too close. There we go. Right, so the order of priority is, if it's chasing the player, it rotates to face the player, chases them, and it moves to them. Our new task has no logic in it yet, but we will come back and add the logic for changing the movement speed of our AI character, after which the AI will move to the enemy actor, in brackets player. Create a new task and rename it BTT Find Random Patrol. Hold on a minute, do I have to create a new task? Create a new task. Okay, new task. Create a new task and rename it BTT Find Random Patrol. BTT Find Random Patrol. And then connect it to patrol. Okay, so BTT Find Random Patrol. I'll go back to blueprint. I'll save. Save. And rename it Find Random Patrol. Then connect it to patrol. BTT Find Random Patrol. Hold on. That's interesting. I labelled it like that, but when you actually go on a drop down, can you see it's put a space between them? I wonder why it does that. Find Random Patrol. Connect it to patrol. Done. Add a move to task. Move to, and set the blackboard key to patrol location. Okay. 4, 5. Okay. Right. Done that. Okay. Move to patrol location. Okay. This will instruct the AI to move to the patrol location. This will instruct the AI to move to the patrol location, which will be set inside the BTT Find Random task. Find Random Patrol task. Right, okay, so we need to add a wait task. We need to add a wait task. We need to add a wait task. Right, this is getting a bit. We need to add a wait task following move to with wait time of 4, random deviation to 1. Okay. Wait. Wait time to 4. random deviation to 1. It's a good job I've got OCD, isn't it? Because like I'm making sure everything's like not just a mess. And the reason why I've moved these down here and not up here is because I didn't like how close it was to the weight. Um, oh, you know what? I'll leave it there. That looks nice and neat. So what we've just done here, the move to the weight, this instructs the AI to wait at patrol location for 3 to 5 seconds. Ah, random deviation adds plus or minus to a second to wait time. Right, so that's basically saying, right, where we've set 4, that's essentially the middle factor. And because we put the deviation of 1, it basically means either side of that 4 is going to be waiting. So almost a little bit of RNG. It's either going to be waiting 3, 4, or 5 seconds. Okay, I understand that. The framework for our behavior tree is complete. In the next step, we will add the logic for changing the movement speed of the AI, finding a random location to navigate to when the AI is patrolling, and the logic for determining when the AI should be chasing the player or patrolling. Oh my god, right, we're going into blueprints. Ooh, it's exciting. Task setup. Chase player. Right, let's just save. In this task, we set up our chase player task to change the movement speed when chasing the player. I just wonder why we've not gone into here and put anything in here yet. I think it said we'll come back to that later, so don't worry, Mike. Inside BTT chase player, BTT chase player, which is here, right click and add an event. Add an event receive execute AI node. Event receive execute AI node. The event receive execute AI node is fired when this task is activated inside the behavior tree. You should always select the AI version of event receive execute. So there's two versions. There's event receive execute and then there's event receive execute AI. You should always select the AI version of if the agent is an AI controller. If both generic and AI events are implemented, only the more suitable one will be called, meaning the AI version is called AI and the generic one otherwise. Right. Off the controlled pawn pin, use a cast to enemy character node. Cast to right. So because we've renamed it, it's going to be cast to wolf underscore character. Off the controlled pawn pin, use a cast to enemy character node. Here we are accessing the character blueprint for our AI called enemy character by using a cast node. So the controlled pawn needs to go up there to the object. Event receive execute AI. Cast to wolf character. Okay. And if I just bring up my thing here, cast to wolf underscore character. Okay. Inside the content drawer, open the enemy character blueprint, enemy character, and add a function called update walk speed. Add function open the wolf character blueprint and add a function called update. Oh, sorry, I'm on the wrong section. Function, here we go. New function. In the content drawer, open the blueprint, add a function called update walk speed. This function will be called from our behavior tree. And will be used to change the AI's movement speed. Technically, we could access the character movement component of the cast list, cast node, in our chase player task and just move players around the task. However, having a behavior tree directly change properties of sub-objects is not a recommended best practice. Instead, we will have the behavior tree called a function inside the character, which will then make the modifications we need. In the details panel, for the update, sorry, hold on guys. In the details panel up here for the update walk speed function, add a float input called new walk speed. New walk speed. Drag the character movement component off of the components tab. Click and drag off the pin. Click and drag off the pin of character movement. And from the actions menu, type in set max walk. Set max walk speed. Set max walk speed. Set max walk speed. Set max walk speed. Okay. Use set max walk speed and connect as shown below. When we call this function from the behavior tree, we can pass through. Hold on. When we call this function from the behavior tree, which is the behavior tree wolf, we can pass through a value to be used as the new speed. Back inside the BTT choose player task, from the as wolf character node, call update walk speed. Update walk speed. So I'll get rid of that. When we call this function from the behavior tree, we can pass through a value to be used back inside the BTT chase players key. Call update walk speed set to 500. Set to 500 and connect as shown. Following update walk speed, add 2 finish execute nodes and connect as shown. Okay. Target self success. Ooh. Why has that just done that? Target self success. Okay. Following update walk speed, add 2 finish execute nodes and connect as shown. Target self success. Target self not a success. Here we mark the task as successfully finishing when we successfully casted the enemy character. If the controlled pawn is not enemy character, we need to handle this case, so we mark the task as unsuccessful, which will abort the task. Okay. Right click the new walk speed pin. Update walk speed. Chase speed. What? What is going on here? Ah, right click, promote it to a variable. And call it chase speed. For chase speed, make sure to enable instance editable. By promoting this to an instance editable variable, the value of max walk speed can be set from outside of this blueprint and will be available as a property inside our behavior tree. And the behavior tree is here, the wolf. So if I click on BTT chase player, What? Why is that not showing? Oh, maybe I need to compile. There we go. Right, so you, I panicked then. I was like, what's going on? It's not there. So you have to click compile on the blueprint, and then we click on here, and we've got the chase speed here. So instead of going in here and setting things, it can be done within the behavior tree. Okay, I think I'm understanding. This is a lot to take on, guys. But we can now easily change the value of chase speed that has been sent to the enemy character blueprint, enabling us to tune and tweak how fast our AI chases the player. Our chase player task is complete. Our chase player task is complete. Oh, 1 second, guys. Bear with me, guys. Okay. Right, our chase task. I'm just going to save it all. Our chase player task, which is this one, is complete. In the next step, we will set up the find random patrol task logic to get a random location for the AI to move to. In this step, right, so task setup, find random patrol. In this step, we set up our find random patrol task, so our AI moves to a random location when it is not chasing the player. Implementing a blueprint behavior tree task is a clever way to quickly iterate, but if performance is a concern, you may decide to move to a native behavior tree task. Inside BTT, so this is blueprint tree, no, behavior tree task. Sorry, there's a lot of acronyms. Um, Hold on. Yeah, okay. Right, inside here, we need to use event receive execute AI. Right, so event receive execute AI and cast to cast to wolf character controlled pawn object. Okay. Off. What? Oh, okay. Off as wolf character. Call update walk speed. So we're slowing them down. So this is saying when we stop chasing the player, we're going to reset the speed back to default. Got you. Okay. Promote new walk speed to variable. Get that. And this will be renamed to patrol speed. click image of full view. Variable name to patrol speed. Instance editable. Patrol speed. Default values set to 125. Okay. Welcome frontal to the stream. Thanks for tuning in. Okay, so patrol speed. Alright, we've done that. Instance editable. Instance editable. Here we are lowering the enemy movement speed while patrolling. Off controlled pawn. Get actor location. Okay. Off controlled pawn. Get actor location. Then hold on, guys. There's quite a lot on the screen here. Oh my god. Alright, one second. There's quite a lot on screen. There is quite a lot on screen here. Right, so off the control pawn, get actor location. Then get random reachable point in radius. Okay. Get random reachable point in radius with the return value connected to a branch. Promote the radius on point in radius. Radius. Promote to the variable. Dude. Okay. Promote the radius to a variable with the following settings. Patrol radius with the following settings. Okay. Variable name. I shouldn't have had a space in that. Instance set to instance editable. Patrol. I don't see anything on here saying default value. I literally don't see anything. Apparently, oh, default values, patrol radius. Oh, you have to compile it right. Right, patrol speed. Oh, what a numpty. 125. I wondered why I wasn't seeing this default value. So patrol speed default value 125. So you compile it and then it shows up, right? Because it's a variable, you've converted it to a variable, you compile it and then it shows up. Always remember to compile. Patrol radius 1000. That's quite large, patrol radius. Here we are finding a random location within 1000 units of the enemy character's current location. That sounds like quite a large distance. Whereas I thought on a first person map this would be it. So if the wolf comes out of this, then we just adjust that parameter, I think. Okay. Here we are finding a random location within 1000 units of the enemy character's current location. We are also using a branch node to handle the edge case that a random point to move to is not found. Off the random location pin, use set blackboard value as, oh my god, this is getting quite messy now. This is getting quite messy. Oh my god. Right, hold on. I need to make sure that this is getting quite full on now. Off the random location pin. Use set blackboard value as a vector. Use another. It's a lot of lines going on. Oh my god. Use another set. Fuck. Set. Right. Use set blackboard value as vector with the key promoted to a variable. With the key promoted to a variable called patrol location. Use another set blackboard value Okay, hold on. I need to adjust the flow here because I've made it nice and neat, but it needs to be just slightly adjusted. Right, so we've got the patrol location. Promote to a variable called patrol location. Use another set blackboard value as vector node with the value coming from get actor location. Set blackboard value as vector node. Right, 1 second guys. Right, so use another one coming from get actor location, which I've done there. It's going across here. Continue from the previous step. What? I can't even see that. Patrol location. Oh, okay, so this is... There's a lot of stuff going on screen here. I'm just tidying this up so it doesn't look a mess. Right, continue from the previous step, which we've done, and connect as shown below with both nodes, resulting in finish, execute, mark success. Use another set blackboard value. Right, continue with both nodes, resulting in finish, execute, mark success. Yeah, okay. I think if the enemy if the enemy finds a random position to move to, it will be stored in a blackboard as the location to move to. If a location is not found, it will use its current location and stay put before trying a new location. We still need to handle the edge case that the controlled pawn is not enemy character. What? We still need to handle the edge case. That the controlled pawn is not enemy character. What does that sentence mean? We still need to handle the edge case that the controlled pawn is not wolf character. Off the cast failed pin of the cast node, just here, of the cast failed pin, use finish execute. Finish execute. Oh, with success disabled. Okay. With finish, use finish execute. So it's disabled. Okay. If the controlled pawn is not enemy character, this task will be marked as unsuccessful and will be aborted. Okay. So if the controlled pawn is not wolf character, this task will be marked as unsuccessful and be aborted. Our final random patrol task is complete. In the next step, we will learn more about decorators and how they can be used as conditionals, as well as set up our AI controller. What's a decorator? AI controller setup. In this next step, we do a little bit of work inside the AI controller in preparation for the final step, setting up a decorator to determine which branch of we're setting up a decorator to determine which branch of our behavior tree to enter. In the content drawer, open the wolf controller blueprint, which is this one. No, wasn't that. Open the enemy controller. So we named it to wolf controller, and this is I believe I'm in the right one. No, I'm not. No, it's this one. Hold on, what is going on here? Open the enemy controller blueprint. What was that message? I don't understand that. I don't know why it popped up. Open the enemy, right, wolf controller blueprint and add an event. Add an event on possess node. I'm not going to delete those two inactive nodes, just in case. Off event on possess, add a run behavior tree. Run behavior tree. With wolf set to BT wolf. Run behavior tree is a contextual function call that targets AI controller class blueprints and enables you to execute the assigned behavior tree asset. In the components window, click add and search for AI perception. AI perception. AI perception, so that's looking. The AI perception component is the AI perception component is used to create a stimuli listener within the AI perception system and gathers registered stimuli. In our case, we can use sight that you can respond to. This will give us the ability to determine when the AI actually sees the player and can react accordingly. In the details panel for the AI perception component, add an AI site config. AI perception. Why can't I see that? AI perception. In the details panel for the AI, add an AI site config. AI site config and enable detect neutrals. Detect neutrals. The detection by affiliation properties enable you to set up team-based AI that fights alongside teammates of the same affiliation and attack members of the opposing affiliation. Actors by default are not assigned an affiliation and are considered neutral. Right, okay. Currently, you cannot assign affiliation through Blueprint, therefore we are enabling the detect neutral flag to detect the player. As an alternative, we are going to use actor tagging to determine which character is the player and force AI characters to only chase actors tagged as player. In the events section for AI perception, hold on. Add event. On target perception updated. In the event section for AI perception, click the plus sign. Well, I've right clicked it. On target perception updated. On target perception updated. Off on target perception updated in the graph. Add an actor has tag node with tag set to player. Off the stimulus pin. Add a break. Off the stimulus pin, add a break AI stimulus node. Okay. Add a branch node with the condition shown below. Okay. Oh, hold on. 1 second, guys. Right, so we've got to do a branch here. Add a branch node with the conditions shown below. Here we are checking if the actor was successfully sensed and if that actor has the tag of the player. So it's saying if they're sensed and they're the player, okay. Right, okay, I've got you. This is making sense. Like I say, I'm trying to learn this. There's quite a lot to take in. I am not even joking. Quite a lot to take in here. Add a branch node with conditions. So this is the boolean. This is a true or false thingy. So if it's that, so if it's that and that, then it goes up to the condition. We're checking if the actor was successfully sensed and if that actor has the tag player. Right, off the false of the branch, set timer, set timer by event. The time being 4 seconds. Okay. Right click and promote time to a variable. Call it line of sight timer. This variable and a value assigned. This variable and a value assigned will determine how long before the AI gives up chasing the player, at which point the attached event will execute. Right click on the return value of set timer by event and promote it to a variable called enemy timer. Enemy timer. To promote it to a variable called enemy timer. This stores a reference. This stores a reference to the timer. It stores a reference to the timer by way of a handle. This handle can be called upon through script to invalidate it itself and clear any associated events, preventing the associated event from being executed. We can use this later in the event. We can use this later in the event the AI sees the player again before the line of sight timer runs out, which stops the AI from losing sight of the player and giving up the chase. Create a custom event and call it, oh my god. Create a custom event and call it start enemy timer and connect it to the event pin of set timer by event. Oh, I didn't. I had to compile it. I was doing it again. What? Oh, it's because I need to drag you numpty. Why is this not? Okay, why is that not working? Create a custom event. Right, I've got. Why am I not getting this option? Create a custom event and call it start enemy timer. And connect it to the event pin. I'm not getting that as an option. What is going on there? Why was it saying context sensitive? Ah, Instance editable. I bet that's why it wasn't showing. Hmm. Oh my god, this is doing my head in. Why is it not showing up? Right, we'll come at a little thing variable. Alright, I've got a bit of a problem here. I have a little bit of a problem here. I have followed all of the steps, word for word. Clear any. Create a custom event. Call it start enemy timer connected to the event pin or set timer. But I'm not getting the option. Event play, event tick, event and possess. Why am I not getting that option? Why am I not getting that option? Oh, you bellend. You absolute bellend. Oh, Mike. I was literally searching for start enemy timer. That's the next bit. You search for custom event, then you name it. Oh, you are an absolute pillock. Oh, you numpty. Oh, I feel like a right idiot. Oh my god. Oh, dearie, dearie me. I feel like an umpty. Oh, dearie me. That was funny. Create a custom event, call it start enemy timer. Now it's showing up on the left hand here. Connect it to the event pin of set timer by event. Boom. Right click. Right click. Okay, so we're doing this bit. Oh, down here. Right, right click, then under variables. Under variables AI, get a Blackboard node. Don't know if that's right. Hold on. Where am I right clicking? The symbol, for some reason on the documentation I've got, it's not the function symbol, it's this, but on the documentation it's got like a sideways omega symbol. But this is, I think, what we need. Get a Blackboard node. I think I've done it right, judging by the document. Off Blackboard, use set value as bool and set off Blackboard, done that, set value as bool, yeah, and set value as object. And connect as shown. Set value as bool. Nodes connected there, and target is there. Okay. This enables us to update the Blackboard keys defined with new values. Oh, why are we getting an error? Oh, it's because we've not finished it yet. Okay. This enables us to update the Blackboard keys defined with new values. Right click and promote both key names to variables. As line of sight. that's that one. Compile the right, and then right to variable. Oh, dude. I want to grab it. There we go. Compile the blueprint, set the default values of both keys, enemy actor. Okay. Right, that's done. Compile, save, all. Right, they're both done. I feel like that's too close. I just want to move that like there. Then okay. Off the true of the branch up here. Off the true of the branch, use get enemy timer. Dude. Right, okay. So on here, it's not get enemy timer, it's off the true of the branch, use get enemy timer, and then I don't know why they're placing this over here. When the AI sees the player, it will clear the line of sight timer until it loses sight of the player again, where a new line of sight timer will start. When the AI sees the player, where a new line of sight timer will start. Copy and paste the blackboard node. Copy and paste blackboard node. Oh my god. This graph's getting crazy. I'm struggling to keep up with what's going on here. Jesus. Copy and paste the blackboard node, which is here. Blackboard has line of sight enemy actor. Oh, okay. So we're copying this stuff from down here. copy, and then oh no, we don't want that one. We want to move that over here. Okay, I think convert, clear and invalidate timer by handle. Oh, 1 second, guys. I've just got an email I need to reply to. Thanks for tuning in to the stream. Sorry, guys. I'm just sending a quick email. Boom. Okay, back to action. Okay, so we've copy and pasted the Blackboard node from down here and basically placed it up here. what's going on here? On the set value as ball node, which is right here, on the set value as ball node, enable the ball value and drag the act pin to the object value. Oh, hold on, sorry. Drag the actor pin. Oh, hold on, what have I done wrong here? We tick that. Oh, this pin goes over to here. This sets the blackboard key values for has line of sight to true and enemy actor to the actor we perceived, which we have set up to only trigger if it is the player. Click compile to compile and then close this blueprint. The final graph should look like that. Why is the event on possess not there? Click compile and close the blueprint. Done. Decorator and final setup. I feel like we're getting close to the end. Let's just save again. In this final section, we adjust a few settings on the player character and enemy character blueprints. We also set up our decorator and our behavior tree, which will determine what branch we can enter. Hold on. We also set up our decorator and our behavior tree, which will determine what branch we can enter based on a specified condition. Inside the content drawer, under content, first person, blueprints, open the third person character blueprint, which is that one. In the details panel over here, search for in the details panel, search for and add a tag. In the details panel, search for and add tag. Mesh, character movement. Search for and add a tag. Right, that isn't showing. You see here. Oh, you can't even see that on the screen I've got up. There's meant to be an image, but it's not showing. So I'm hoping this is done right. We've added an array element saying player. So without the image on the Unreal documentation, I'm hoping that's right. We've been on the details panel, we searched for and add a tag set to player. So if I just clear that, hold on. Why did that not? I think I've done that right. We'll find out, won't we? We will find out. By adding this tag of player, the AI can now perceive and react to the player. Open up the wolf character blueprint. Open up the wolf character. Hold on. Open up the wolf character blueprint inside your AI folder. In the details panel, search for rotation. What the? Oh, fuck, what have I just clicked? Where has that just gone? What? Guys, I've been doing this for nearly 2.5 hours. This is really, really full on. Open up the enemy character blueprint. I literally, this is it. This is, why do I feel like this is wrong? This is stressing me out now. Open up the enemy character blueprint inside your AI folder. Done that. The wolf character, because I renamed it, not enemy character, it's wolf character. In the details panel, search for rotation. I'm not getting any search option. I've got a very strange feeling here. Give me 1 second, guys. Let's just hide that. Right, it's saying don't see the pawn options. You may need to click the class default buttons. Open up the enemy character details panel. On the details panel, search for rotation. Search for rotation and use enable use controller rotation yaw. That's done. This will cause the AI to rotate properly when rotate to face BB entry is called from a behavior tree. Open up the PT wolf. That's blackboard tree. Behavior tree wolf. Hold on. Behavior tree wolf. Open and right click on chase player. Add decorator. Select blackboard. Oh, BT. That's just made that really. No. Just going to move that over there. Open up the BT Wolf, done. And right click on Choose Player. Under Decorator, select Blackboard. Done that. When you right click on the node in a behavior tree, you can add subnodes that provide additional functionality. Decorator, also known as conditionals. These attach to another node and make decisions on whether or not a branch in that tree or even a single node can be executed. Service. These attach to both task and composite nodes and will execute at their defined frequency as long as their branch has been executed. These are often used to make checks and to update the blackboard. These take the place of traditional parallel nodes in other behavior tree systems. We are going to use the blackboard decorator to determine the value of a blackboard key, which when valid is going to allow this branch to execute. Okay, select the blackboard based condition that was added and set the following settings in the details panel. Observer aborts both. Blackboard key has line of sight. Description. Node name has line of sight. Question mark has line of sight, then boom, it chases player. So it checks the blackboard functions and then chase player. Okay. Okay. So observer aborts to both. Blackboard key to has line of sight. And then node name has line of sight. Here we are stating that when the has line of sight value is set or is true, execute the chase branch. So it rotates, chases at speed and moves towards them. The observer aborts setting of both states that when the blackboard key we assign changes, abort ourself, chase player, and any low priority tasks. This means that when the value has line of sight changes and is not set, abort self, chase player, at which point the next branch, patrol, will execute when the has line of sight value is set. The observer will abort lower priority tasks as well enabling the chase player branch to be executed. Compile and close. Well, there isn't an option to click compile on here. Compile and close the behavior tree. Okay. Right, here's the test. Oh my god. Right, so this is the wolf character. So we need to assign the mesh. There it is. Animation mode. Use animation asset. And it's going to be, we'll have wolf walk my god. This is the moment of truth, guys. Of course it doesn't work. Oh, actually, maybe. Maybe that's because I wasn't in line of sight. Let me just read this. I think. Hmm. It's not following me, is it? Hmm. God, that's annoying. I spent 2.5 hours doing that, and it's not. I wonder if it's. I just need to check my sugars, guys. Give me a minute. I wonder why that didn't work. I have a feeling. So that's the player start, and that is I think I know what's happened. And I've got a feeling it's because I didn't follow. Right, I'm just going to save this and then we're just going to go through and we're basically going to go back through all the steps and just quickly rename it as it's saying we should, instead of putting wolf. One second, guys. Sorry guys, just had to take the call. Right, so what I'm trying to do, I'm trying to backstep over what we've done. Um, I'm just going to quickly whiz back through and make sure that I've followed their naming, because I basically changed everything to be like wolf. And I think because at points there's been like enemy, it's not linking up. I think that's what the problem is. So it's my own fault. Um, oh, this is annoying. Okay, yeah. Right, I'm whizzing through this, guys. Just bear with me. Baby tree enemy. Blackboard enemy. Okay. I'm just whizzing through the Unreal documentation here. Just bear with me, guys. BTT chase player. Blackboard, control location, yep. Wait time, yep. Chase player. BTT chase player, okay. I need to change it to cost enemy character. Oh, it's just updated it. Okay. That literally just said wolf character. BTT chase player. Cost enemy character, chase speed. I'm whizzing through it, guys. Go back to the BT enemy, chase player, 500. Find cost enemy player. Yep. Open the enemy controller. Open the enemy controller, event on possess. BT enemy. Yeah, it's already done that. And then it went through all of those steps of let's test it now. You're not chasing me, are you, mate? And you're not moving. Why are you not moving? Oh, fuck me. This is annoying. Why are you not working, mate? I think I know why you're looking over there, aren't you? You are looking at this. Why are you not coming after me? Oh God, this is so frustrating. Oh, I've got a headache. Oh, hold on a minute. Hold on a minute. I haven't. Wolf character. Why has it got arms? Oh my God. We need to change that camera angle, I think. think we need to have a tag player. I've got shit AI. Oh my god. Why are you not moving, dude? Hold on. What is going on with that? Why does it feel like that is... No, that is correct. Hmm. Why are you using those arms, dude? Why? First person camera, first person match. Skeletal match. I think I know what I've done wrong. I think I know what I've done wrong. I think I know what I've just done wrong. Fuck. Ah, I know what I've done wrong. Oh no, 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 no. I think I know what I've just done wrong. Oh no, no, no. Oh, dude, I am so pissed at myself. I know what I've done wrong. I know what I've done wrong. Oh, I know what I've done wrong. I've used the first. Oh, such a twat. I'm pretty sure I've figured out what I've done wrong. So because I was playing as the first person, I've stupidly done the enemy character as a first person when it should have been third. I feel like such an idiot. I feel like such an idiot. Right, okay. Oh, dude. Right. Oh my god, I'm such an idiot. I think I know what I've done wrong, guys. Oh, fuck. Feel exhaust. Why is that not coming up? First person enemy. I'm such an idiot. I'm pretty sure I know what I've done wrong. I feel exhausted. Oh, I feel exhausted from this. Come on, I'm literally at the end of this. I just. We're looking for. I don't even know if this is right. I mean, what? Why is he not even showing? Oh my god, I've messed it up. Oh, fuck. I've messed it up already. It's not even moving, dude. Sorry, I'm not talking. Oh my god, he's gone now. Oh my god, why is my phone going off? Right, guys, I'm gonna have to take a break. I'm a little bit exhausted from this. I've been at it for 3 hours 20. I've not eaten today, which is not good. I need to go and eat. I need to go to the shop. I think it's a good stage to take a break because I'm just a bit numb. Just I don't know if the problem is that we're following a tutorial, third person character, and we're in a first person template. I don't know if that's the problem. I don't see how it would be, but because that blueprint for the enemy character is it's essentially. Let me just figure this out quickly because it's bugging me. I think I know what I've done. I'm sorry I'm not talking. I'm concentrating here, guys. Dude, why are you not selecting that? Oh my god. Let's just quickly fix this mesh. Oh, oh, it's so annoying. Why is it not doing what it's supposed to be doing, mate? Is it because of this box? Is it because the box is... I'm just going to make that the entire level. There you go. It's like, what's happening? It's like when it sees me, it's changing direction. It's not coming at me. First person character. It's like I need to give... I need to merge all of those assets into the house as well. I need to create a folder for that for shack. I'll hide the cubes. Oh, dark. So this, I think, is all the stuff that I've made. I need to take a break, guys. I will be back later. Yeah, I need a break. This has been interesting. It's been very long. We've come across a problem. We need to figure it out. I genuinely think this whole problem is because we're in a first-person environment and the template I've been following is third person. I think that's why we're not getting chased and why the wolf's not doing what it should be doing. Yeah, let's see what happens in the next stream. I just need to take like an hour and a half break, and then we'll come back to it, guys. Thanks for watching. If you enjoyed it, give us a follow, and I'll see you in the next stream. Ciao, ciao.